Okay, now on to the guided practice. So the first two questions are just pure computation. Can you type them in the calculator and get an answer? That's all I'm checking to see. And there's different ways you could do this. The first way is to notice that, oh, 11 minus 3 is 8. So you could say 11 factorial divided by 8 factorial. So I'm going to do that just to kind of remind y'all how to put the factorial in the calculator. I'll like I said, just to remind y'all, I'll show y'all two different ways. First, you can do 11, the menu, probability, factorial. Why didn't it do it? Hang on. Menu 5, 1. There we go. You could do that way, or you could do the one where it says, okay, well, first you got to type your number, and then beside the G, there's like the question mark, the exclamation point, etc. Hit that button and pick exclamation mark. That'll get you 990. So that's certainly one way to do this. You'll get 990 as your answer. Also, you could say, okay, well, I see the P here. This must be a permutation. So in your calculator, you could do NPR 11,3. That would get you the same thing. Okay, number 2. We could do the combination here. NCR, there it is. So we could just type this first piece right here straight into the calculator and easily get your answer. So let's do it. Menu, probability, combination. We'll need to do 11, put a comma in there, then a 3, and get the answer of 165. So the middle piece, that's just breaking up and actually using the formula for a combination. You're more than welcome to type this thing using just the factorials. You can type that in the calculator and you'll get the same answer. So there's multiple ways you could do this. Okay, number 3. There are 23 students in a high school geometry class, and they are tasked to form a group of 5 representatives. How many different groups can be formed? Well, let's see. We're just forming a group. That's all we're doing. We're forming a group. So does order matter? No, order does not matter. And can one person serve multiple positions in this group? It doesn't say, but we're going to say no, they can't. So we're doing it without replacement. Which means this is a combination. Okay, so how many do we have to pick from? Well, it says there's 23 students in the class, so that means we've got 23 to pick from. That's our N. N is 23. How many are we actually picking? we need a group of 5. So 5 is our R. We can do this as NCR 23, 5. Since this is a combination, that tells us which one to use. At this point, it just becomes a calculator problem. Plug it in. So menu, probability, and combination. We have 23 that we can pick from, and we're picking 5 of them. It's 33,649. That's how many different groups there could be. Okay, number 4. Lufkin's JV basketball team has 12 athletes on their team. The coach is going to choose 5 players to start the game at random. How many different starting lineups are possible? Well, let's see. Does order matter? If coach tells you to get out there and play, does it matter the order? No, you're going to get out there and you're going to play. Or get yelled at by the coach, your option. But chances are you're going to go out there and play. So order does not matter. If you're playing basketball, can you play multiple positions at one time? No. So we're doing it without replacement. He can't pick you again to go out there if he's already told you to get out on the court. That means we have a combination that we're dealing with. Okay, well, how many does he have to pick from? He's got 12 athletes. And how many is he picking? 5. So we have a combination where he has 12 and he's picking 5. Put that in your calculator. It's going to be 792 different lineups. $792 different starting lineups. Okay, number 5. If 3 points are randomly chosen from those on the pentagon shown, what's the probability that they all lie on the same line? This is just like that example that we saw in the notes. Except instead of a rectangle, now we have a pentagon. So how many points are there total on our pentagon? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 total. So N is 10. How many are we picking? picking 3. So R is 3. It doesn't matter the order we pick, and we can't pick a point more than once. So this is a combination. So let's figure out how many total ways there are. Then we'll look at how many favorable ways. So we're doing a combination where we have 10 and we're picking 3. So menu, probability, combination. We have 10 and we're picking 3 of them. That means there's 120 possibilities. Now we have to figure out how many ways are desirable. Well, we need to have 3 in a row. So there's 1, 2, 3, 4. There's 5 favorable ways. So the probability will be 5 divided by 120, which reduces to 1 over 24. As a decimal, that would be 0.0417. So that's the probability. Of course, again, with probabilities, decimals don't tell us much, but percentages do. So we've got a 4.17% chance of getting a desirable outcome. Okay, number 6. The Texas two-step lottery has 2 steps in choosing numbers. Step 1, we have to choose 4 numbers without repeating from 1 to 35. The order does not matter. So order does not matter. And we do it without repeating. This is a combination. Let's just stop there and deal with step 1. So step 1 is a combination. Okay, how many numbers can we pick from? We've got 35 to pick from, and we're picking 4 of them. So total ways for step 1 to happen would be menu 5.1, clear. Sorry, menu 5.3 combination. We want to do 35, and we're picking 4. 52,360 ways. That's how many ways step 1 can occur. Okay, now let's read on to step 2. So step 2, you choose 1 bonus ball that can be any number from 1 to 35. So for step 2, we just pick 1 ball that can be 1 to 35. So how many options are there? There's 35 ways that could happen. So total, we would have to do that 52,360 times 35. So times 35. That means there's going to be 1,832,600 ways for this to happen. But it doesn't stop there. But wait, there's more. What's the probability that the winning jackpot numbers are? 34, 15, 2, 3, that's your group of 4, and then 17 for the bonus ball. Well, how many outcomes is this? This is just one outcome. Let's say those are your numbers. So the probability that you win would be 1 over 1,832,600, which as a decimal would be what? So I have 6 zeros in front. 0.1, 2, 3, 4, 5, 6. And 5, 4, 6. 5, 4, 6. That's the probability as a decimal. As a percent, we just move our decimal place 2 to the right. 0, 0, 4, 5, 4. Yeah. Again, slim chance of you winning the lotto. I mean, it's got to be a slim chance. If you think about it, they're not going to just give away money. If that's the case, it wouldn't be called the Texas two-step lottery. It'd be the Texas two-step giveaway. Okay, number 7. How many lines are determined by 10 randomly selected points where no 3 of which are collinear? Okay, so if I'm making a line here, let's say I want to make a line from here to here. How many points do I need? I just need those 2 and I can draw a straight line between it. Except for the fact that I can't draw a straight line, so yeah. Anyways, you just need 2 points to make a line. So I'm gonna write that here. 2 points make a line. How many lines? It takes 2 points to make a line. Okay, we have 10 that we can pick from. We've got 10 we can pick from. We don't want 3 to be collinear. No 3 are collinear. So we've got 10, we're picking 2. Does the order matter? If I'm making a line between these 2 points here, does it matter whether I pick the bottom one first or the top one first? No. Order doesn't matter. Obviously, I can't pick the same point twice. It wouldn't be a line. So this is a combination. N is 10. R is 2. So we've got a combination where we have 10 and we're picking 2. So menu, probability, combination. We have 10 points and we're picking 2 of them. That gives us 45 options. So there's 45 lines. 45 lines. There's our answer. Okay, so that's the guided practice. On your assignment, you have 19 problems. We just did 7 together. You only have 12 left to do on your own. They're pretty similar to the ones we just did. So jump to it. If you have questions, you know how to reach me.